not a lot of current, but enough to do some work. The article says that you can charge a battery with this if you have several of these in series. You can actually power your house if you put 200 of them in series. Well, I thought, well, I'll try to light an LED. So we've got one laying here. And if you watch closely, you will see it flash as the capacitors discharge. See there? Flash, flash, flash. So I'm letting it charge and then discharging it through the LED. Now, as you can see, it's lit up. It's not very bright, but it's only got about 1.4 volts across it. And if you take two of these boards and put them in series, that'd be enough to really light this thing up. And just a few more, you could actually light up your whole room with these things. And the energy is free. There's absolutely nobody charging for this at all. And you watch as I disconnect the antenna. I'm going to try to zero in here on this LED. Okay, about right there. I'm going to unhook the antenna. There you go. Didn't take long, it's gone. And hook it back, there it is, and so forth. And all I'm doing is just touching this wire on my antenna.
I want to show you this curious circuit for energy harvesting of electromagnetic waves. It works by collecting the signals around us through the antenna, rectifies those signals, and stores the energy in capacitors. We are surrounded by electromagnetic waves from radio signals, Wi-Fi, cell phones. All of them are a form of energy, and we can capture it. However, as we will see, it is a very small amount. So here's the circuit. The antenna is connected at this point, and the energy is stored in these capacitors. As an antenna, I am only using a piece of wire that is hanging from the ceiling. So let me connect the circuit to the multimeter. And you can see a voltage of 0.6 volts. And let's connect the antenna. And the voltage is now rising as the capacitors start to charge. So now we have a voltage of close to 3 volts, and it can go at around 4 volts. So let's now connect this LED to the circuit to use the energy that we have stored. So watch when the LED lights up what happens with the voltage. You see that the voltage goes down because we used the energy stored in the capacitors, and the LED only lights up for a fraction of a second. So it is very little energy that we have in the circuit. Let's do it again. Watch the LED and the voltage. Again. The LED needs about 2.2 volts to work. So let's do it again.
this is my little radio frequency signal diode rectifier. You can pull energy out of the air and the ground. I mounted it on a little board. Scrap the board, just screw it in. So what we've got are two ceramic capacitors. There's four germanium diodes, and then there's two electrolytic capacitors. And I'm using this just to show what kind of power you can get from an antenna and a ground. Okay, I've shorted out the capacitors. The antenna and the ground aren't hooked up. I'm going to go ahead and hook up the ground and the antenna. We'll go ground first. Doesn't make a lot of difference. I'm going to hook up the antenna. There we go. You can see the voltage is coming up. Okay, before I put the battery in, I just wanted to show you what I've moved the pickup wires to the battery charging terminals. There's a little Zener diode there, and it's reverse biased. So what's happening is our circuit has to put out about 400 millivolts. Watch it. Right at 400, it throws a high voltage spike out. See it? That starts over. So I'm going to go up to 400 again. Bang. Okay. Alright, I wanted to show you what the output is and how fast it runs. I've just got a little LED instead of the battery. And you can see how quickly this cycles.